Let's go on a fishing trip. Well, next best thing, answer a calculus problem about a fishing trip. So, fishing boat is 80 kilometers from its port. Great, so we have its port. We have a distance of 80 kilometers. And we have our fishing boat. Beautiful. Fishing rods out the back. So now it's at its fishing grounds. Fishing grounds. It accelerates in a straight line directly away from its port. So it's going to continue. In this case, I've drawn it to the right, but direction doesn't matter. So as long as it's going away from the port, and we are given the acceleration as a function of time in terms of hours. Now, the speed of the boat is 3 kilometers per hour when it starts fishing. During which hour did the boat travel 11.75 kilometers? Well, so let's be honest, this is quite a confusing kinematics problem because there's so many things going on, but we'll break it down. So to start, a diagram helps me at least. So we know its initial speed is 3 kilometers per hour when it's at the fishing grounds, right at this point right here. So this is like our starting point. So that's its initial speed. We also know its acceleration at that time of 0.5 kilometers per hour squared. All right, and we are looking for the hour, so we're looking for a time given it traveled a certain distance. Right, so as the fishing boat is moving along, there'll be 1 hour in which it travels 11.75 kilometers. Alright, so where to start? Firstly, we can actually ignore the port at the start there because we don't really start the stopwatch until the boat is at the fishing grounds. So this will simplify the problem. So taking this point right here as the starting point. Let's just move that to the side. So what do we know? We know acceleration is 0.5. Cool. So a reminder for kinematics, distance, speed, and acceleration are related through differentiation and anti-differentiation. So the derivative of distance is speed, the derivative of velocity is acceleration, the antiderivative of acceleration is speed, the antiderivative of speed is distance. And so we are given acceleration. Ultimately, we're looking for time related to a distance. So we're going to want to get our distance equation. All right, so let's work our way towards that. So from acceleration to get speed, we anti-differentiate. So the antiderivative of 0.5 is 0.5t plus our integration constant. Right? And in a kinematics problem, what that integration constant means is what is the initial speed. Right? Well, we know the speed of the boat when it starts fishing, so at the orange point, is 3. So as a point, that's when time is 0, speed is equal to 3. So we could substitute 0 in for t and 3 in for v, and we would get that c equals 3. Right, the initial speed. So just as an equation, the speed is 0.5t plus 3. Right? Again, the 3 is the speed when the boat starts fishing. Okay, so we've already found the speed equation. What's next? So finding the distance equation. right, or displacement. So the distance equation is the antiderivative of the speed equation. So like before, the antiderivative of 0.5t is 0.5t squared, right? We add 1 to the power divided by that new power. The antiderivative of plus 3 is plus 3t. And of course, we have a new integration constant plus c. Cool. Alright, now what is the initial distance of the boat? So here's where you could think of it in two ways. If you included the port, like we did before, the distance from the port is 80 meters. Right, so that could be your value for C. However, I've just ignored the port because it's not relevant to the boat traveling in the fishing grounds. So actually our initial distance at time 0 is 0 meters, because we start the stopwatch as the boat enters the fishing ground. Right. So if you used plus 80 here, absolutely fine. However, how I've solved it, C is actually 0, so we're left with, so what's that, a half divided by 2 is a quarter, so what's that, 0.25 t squared, that 2's in the way, so 0.25 t squared plus 3t plus 0. Right, and just on the side, I'll write where I get the 0 from for C. So when distance is 0, time is 0. And actually up here, when speed was 0, when time was 0, speed was 3. Just showing where I got my values for C from. Okay, but so far now, we have found the distance equation as 0.25 t squared plus 3t. Alright, now what's next? Looking at the question, we're looking for a time that the boat, we're looking for the hour, right, so an interval of time that the boat has traveled 11.75 kilometers. Alright, so how are we going to find this? So we have our distance equation. So to use it for an interval, right, it's a little bit different than just substituting in the distance to get a time, right, because we're looking for the hour in which they traveled a distance. So as an equation, we want the distance they traveled at some time plus 1 hour, and from that we will take away the distance they traveled like an hour before. And we know that that difference in distance will equal 11.75 kilometers. So just one more time, the t plus 1 represents 1 hour ahead of the t. So that interval will be 1 hour. And so the difference in those distances needs to equal 11.75 to find the hour in which they traveled 11.75 kilometers. Cool. So now we've expressed that, we can now use our distance equation, and instead of time, we will substitute in time plus 1. And then for the second part, that's just substituting in time. So we get 0.25 instead of time, we have time plus 1 squared, plus 3 times time, where time is now plus 1. So that is d of t plus 1. Similarly, now we will subtract d of t, which is just as it is, minus 0.25 t squared. Now careful here, we're subtracting the 3t as well, so I'll use my brackets. And we know that that difference will equal 11.75. Alright, so now we've formed our mammoth equation, but again, this will simplify down a lot. So let's just expand it out and simplify. So here's where the algebra kicks in. So foiling this out, t squared plus 2t plus 1 plus 3t plus 3 minus 0.25 t squared minus 3t equals 11.75. I can already see some cancellation, so that's great. Expanding out the first bracket, 0.25 t squared, so what's that, a quarter times 2 is a half, so 0.5 t plus 0.25. So that's expanded, then we have plus 3 minus 0.25 t squared. Great, I see some more cancellation, so minus 0.25 t squared and 0.25 t squared cancel. And then we have 0.5 t. Let's group some of these numbers, so that's 3.25 equals 11.75. Now I'll subtract, so we're solving for t, right? The hour in which they travel this distance, so I'll subtract 3.25 from both sides. So subtracting that, what do we get? 11.75, 8.5. Now solving for t, dividing by 0.5. So 8.5 divided by a half is 17. So what does that mean? T equals 17. So, because it's asking us for, like, in which hour it traveled that distance. So we got 17 from the difference in t plus 1 and t, which means in the 17th hour, it hasn't traveled 11.75. However, in the 18th hour, it has. So just to check that, we could substitute in 17 in for distance. So into d of t, and then substitute 18 in for distance. And that difference will be 11.75. How else can you think of this? Because honestly, I'm a bit confused at how I just explained that. So looking back at this equation, the t is 17. So we start at the end of the 17th hour. And when we stop the stopwatch, we're now at the 18th hour. So in the 18th hour, the boat has traveled 11.75 kilometers. So, in the 18th hour, the boat has traveled 11.75 kilometers. Cool, so to recap this question, it is a kinematics problem, right? We were given the acceleration equation. The question was asking us for a time related to a distance, so we had to start at acceleration, take the antiderivative to get speed, the antiderivative again to get distance, all the while solving for the integration constant c. So if you found the velocity equation with the initial speed of 3, that would be achieved. If you went on to find the distance equation, right, either with plus 80 or plus 0, depends how you define it, that would be merit. And then if you went on to form this equation and start to solve for t, that would be a low excellence. If you then went on to correctly solve it and write the correct conclusion, that would be a high excellence. Right, so a lot of opportunity in this question to demonstrate your calculus knowledge. Even if you didn't quite get all the way, part way is still a solid merit or even a low excellence.